Welcome to MathGPT. Today we're going to explore the terrestrial planets of our solar system: Mercury, Venus, Earth, and Mars. These rocky worlds are fascinating and unique, each with their own distinct characteristics. Let's dive in and learn what makes these planets special. Let's start with the basics. What exactly are terrestrial planets? The word terrestrial comes from the Latin word terra, which means earth. So terrestrial planets are essentially Earth-like planets. These include Mercury, Venus, Earth, and Mars, the four innermost planets of our solar system. In our solar system, we have 8 planets total. The inner 4 planets are terrestrial, while the outer 4, Jupiter, Saturn, Uranus, and Neptune, are gas giants. Now, let's discuss the key characteristics that define terrestrial planets. First, all terrestrial planets are located in the inner solar system, closer to the Sun, and inside the asteroid belt. Second, they're primarily composed of rocky materials like silicates and metals such as iron and nickel. This gives them solid surfaces that you could, theoretically, stand on. Third, terrestrial planets typically have a similar internal structure with 3 main layers: a dense metallic core, primarily made of iron and nickel, a rocky mantle composed of silicate minerals, and a relatively thin solid crust on the outside. Fourth, compared to the gas giants, terrestrial planets are smaller and less massive, but they have higher densities, typically between 3 and 5.5 grams per cubic centimeter. Fifth, they have relatively thin atmospheres compared to the gas giants. Each planet's atmosphere varies significantly, which we'll discuss in more detail shortly. Finally, terrestrial planets display various surface features like craters, mountains, valleys, volcanoes, and canyons. Unlike gas giants, they typically have no rings and few, if any, moons. Now, let's explore each of the terrestrial planets individually, starting with Mercury. Mercury is the smallest terrestrial planet and the closest to the Sun, orbiting at an average distance of just 58 million kilometers. Due to its proximity to the Sun and lack of a substantial atmosphere, Mercury experiences extreme temperature variations. During the day, temperatures can reach a scorching 430 degrees Celsius, while at night they can plummet to negative 180 degrees Celsius. The surface of Mercury is heavily cratered, similar to our moon, and has expansive plains and tall cliffs called scarps that formed as the planet cooled and contracted. Mercury has a diameter of about 4,880 kilometers, almost no atmosphere, no moons, a very slow rotation. It takes 59 Earth days to complete one rotation, and a year that lasts just 88 Earth days. Interestingly, despite its small size, Mercury has a relatively large core that makes up about 60% of its volume, much larger proportionally than Earth's core. Next, let's move on to Venus, the second planet from the Sun, and often called Earth's sister planet, due to its similar size and mass. Venus orbits the Sun at an average distance of about 108 million kilometers. What makes Venus truly unique is its incredibly thick atmosphere, composed primarily of carbon dioxide with clouds of sulfuric acid. This creates a runaway greenhouse effect, making Venus the hottest planet in our solar system, with surface temperatures reaching an incredible 470 degrees Celsius, hot enough to melt lead. Venus also has a very unusual rotation. It rotates in the opposite direction to most planets, a phenomenon known as retrograde rotation. Additionally, a day on Venus is longer than its year. It takes 243 Earth days to complete one rotation, but only 225 Earth days to orbit the Sun. The surface of Venus is relatively young geologically, with extensive volcanic features and few impact craters. This suggests the surface was completely reshaped by volcanic activity about 300 to 500 million years ago. Venus has a diameter of about 12,104 kilometers, a thick, toxic atmosphere, no moons, and extreme surface pressure, about 92 times that of Earth, similar to being 900 meters deep in Earth's oceans. Next is our home planet, Earth, the third planet from the Sun, and the only known world to harbor life. Earth orbits the Sun at an average distance of about 150 million kilometers, a distance that has proven perfect for supporting life as we know it. One of Earth's most distinctive features is its abundance of liquid water, covering about 70% of its surface. This water, along with Earth's atmosphere and magnetic field, creates conditions suitable for life. Earth's atmosphere is composed primarily of nitrogen and oxygen, with trace amounts of other gases. This atmosphere not only provides the air we breathe, but also protects us from harmful solar radiation and helps regulate our planet's temperature. Geologically, Earth is active with plate tectonics, which causes the movement of continents, mountain formation, volcanic activity, and earthquakes. This geological activity has shaped Earth's surface and contributed to its biodiversity. Earth has a diameter of about 12,742 kilometers, one natural satellite, the Moon, a 24-hour rotation period, and a year that lasts 365.25 days. What truly sets Earth apart from other terrestrial planets is its ability to support a wide variety of life forms. The combination of liquid water, a suitable distance from the sun, and a protective atmosphere has created a unique oasis in our solar system. Finally, let's explore Mars, the fourth planet from the sun, and often called the red planet due to its reddish appearance. Mars orbits the sun at an average distance of about 228 million kilometers. The surface of Mars is characterized by its distinctive red color caused by iron oxide, or rust, in its soil. Mars also features some of the most impressive geological features in our solar system, including Olympus Mons, the largest volcano, and Valles Marineris, a canyon system that would stretch across the United States. Although Mars is now a cold, desert world, evidence suggests it once had a warmer, wetter climate with rivers, lakes, and possibly even oceans. This has made Mars a prime target in the search for past or present extraterrestrial life. Mars has a thin atmosphere composed mainly of carbon dioxide, with traces of nitrogen and argon. This thin atmosphere provides little protection from meteor impacts and solar radiation, and it's too thin to support liquid water on the surface today. Mars has a diameter of about 6,779 kilometers, two small moons, Phobos and Deimos, a rotation period of about 24.6 hours similar to Earth, and a year that lasts about 687 Earth days. Mars has been the focus of numerous exploration missions, including rovers like Curiosity and Perseverance, which continue to study the planet's geology and search for signs of past microbial life. Now that we've explored each terrestrial planet individually, let's compare them side by side to better understand their similarities and differences. First, let's look at their relative sizes. Earth and Venus are similar in size, while Mars is about half their diameter, and Mercury is even smaller. Next, their distances from the Sun significantly affect their surface temperatures. Mercury, being closest to the Sun, experiences extreme heat during the day. Venus, due to its thick atmosphere and greenhouse effect, is actually the hottest planet. Earth's distance provides a temperate climate ideal for life, while Mars is colder due to its greater distance and thin atmosphere. Their atmospheres also vary dramatically. Mercury has virtually no atmosphere. Venus has an extremely thick and toxic one. Earth has a balanced atmosphere that supports life, and Mars has a very thin atmosphere. This table summarizes key facts about each terrestrial planet. Mercury, diameter 4,880 kilometers, no significant atmosphere, no moons. Venus, diameter 12,104 kilometers, thick carbon dioxide atmosphere, no moons. Earth, diameter 12,742 kilometers, nitrogen-oxygen atmosphere, one moon. Mars, diameter 6,779 kilometers, thin carbon dioxide atmosphere, two moons. To summarize what we've learned about the terrestrial planets are the four innermost planets in our solar system: Mercury, Venus, Earth, and Mars. They're characterized by their rocky compositions, solid surfaces, and relatively compact sizes compared to the gas giants. Each planet has unique features: Mercury with its extreme temperature variations and cratered surface, Venus with its thick atmosphere and extreme greenhouse effect, Earth with its life-supporting conditions and abundant water, Mars with its reddish appearance, and evidence of past water. Studying these planets helps us understand not only our place in the solar system, but also the factors that make Earth uniquely capable of supporting life as we know it. As we continue to explore these worlds with increasingly sophisticated technology, we'll undoubtedly uncover more fascinating details about our terrestrial planetary neighbors. Thank you for joining me on this journey through the terrestrial planets of our solar system.